Okay, so 2020 question 6. So this is the ExamCraft mock. This is our mock, so this will be referenced as mock 1. Okay, so we're going to do the conic section. So I'm going to do a video tutorial, and basically you can just fast forward yourselves. Don't have me slowing you down, don't be waiting for me, or if you just want to go to a section where you got stuck, tip on yourself to that, because I'm going to go through the question in full. So first things first, I'm just going to stick up the question for myself. So that's it there. Question 6, the conics section. So we're given a parabola with vertex B, and we're also given an ellipse, and we're told that the arc DEF is tangential to the ellipse. A and C are focal points on the ellipse. First things first, I'm going to go ahead and I'm going to try to construct the parabola. And just before we start, anything I have in red is construction. Anything in black basically is something that should be in heavy. And sometimes I might use blue, and that's just instruction. Okay, so that's just given a measurement or given something important that I feel needs to be put in. Alright, first things first, I like to set off my drawings just nice and light, just a horizontal line across the page, just to get it started. Okay, so we're told the width of our parabola at the bottom is 100. Alright, so I'll just come in here and I'll measure 100. So that'll be my bottom left starting point. I'll measure in 100. There you are there, and I'll just come in 50 from halfway, and that'll help me find the vertex. So vertical line. Okay. We're told the vertex B is 66 high. So I don't measure in thin air, I'm going to measure along my line. So come along, there's 66. Lovely. Sorry. Okay, so I'll just do another horizontal line there. So that's the top of our vertex. Right. So I'm going to label that. So that's A, that's B, and then my vertex is C. Okay, first things first, we know how to construct a parabola. Right, so I'm going to use the rectangle method. Okay, so what you have to do is bisect this line here and bisect the left hand side as well, the same number of parts. So to bisect the line into a number of equal parts, you just go off at any angle. So I'm just going to choose, I'll go with 3, that should be enough. Do you know what we want? We'll go 4. 1, 2, 3, and 4. So you notice that the distance on my compass was the same, each mark there. And a part here, a lot of people get confused when dividing a number into dividing a line into a number of equal parts. The last point will go to the end of the line. Do not bring it to a random point on the line. Right, so it goes to the last point of the line. There you go, and you're bringing them all parallel using sliding set squares. Great, it's the same on the left hand side. So same distance on my compass when I'm marking it 4 times. So 1, 2, 3, and 4, and same again. You're bringing the last point to the end of the line, and you're sliding along then using sliding set squares, bringing them parallel. So there's 1, 2, 3, and 4. So you'll see a divided line into a number of 4 equal parts. So now I'm just going to number them. So the way I always remember it, I think we spoke about, this is the goalkeeper up here, and number 1 will always be the goalkeeper's number. So that'll be 1, 2, 3, and number 1, 2, and 3. So bringing number 3 to the vertex, so anything opposite the vertex line, so anything over here goes back to the vertex. And then you're just bringing these ones parallel to the axis. So there you can see the curve starting to develop already. So there's 3, 2, and 1. So you just match them up with their bodies, and then it's just a freehand curve. Okay, so you can see my curve starting to develop, and I'll actually put that in heavy. Okay, so you can just use the mirror image method here to bring the points across. There's no need to do the construction on the other side. So this is axiosymmetry. You will also see this in transformation geometry. So I'll just take the distance 1 to the axis, mark the other side, take the distance that the point 2 is met, bring them to the other side, and similarly with 3. Bring them to the other side. And there you have the other half of my curve. So again, just a freehand. And that's the curve completed. Okay, so that's the parabola, so that's one part. I'll just put in the circle in the middle, which is a radius 25. So as I said, always measure along a line. Don't measure on thin air, and then extend your compass. So there you have the semicircle in the middle, and you know the parabola comes in to meet that semicircle, or to meet that circle, sorry. So I'm just going to go over the circle heavy. I know it's hard to see in the visualizer. Perfect. Right. Now we're going to construct our ellipse. So what we're given on our ellipse is we're given A, and sorry, that should be B up here, and this is actually C on here. So we're told A and C are focal points on our ellipse, and we're actually given a point on our ellipse. So we're told, I'll just show you in the question, this is very important. So I'll just show you. So this 18 mil and that 38 distance high, so that point there that they're given on our ellipse, okay, so that is a point on our ellipse, and it's also a point on our parabola. So if we can find that, we know that any distance from our focal point, from a focal point to a point on the ellipse to our other focal point, if you add both of those together, so x, that distance there, and y, if you add both of those together, you're getting the full major axis, which is something we don't actually have at the moment. So that'll be very handy. So I'm going to come in 18 and I'm going to measure up 38, and I'm going to find that point. So down here I'll just measure in 18. Okay, so what you might find is that when you measure in 18, so I'll just show you here. So when you measure in 18 and you measure up 38, you might find that it doesn't hit bang on Well, it does. We're actually okay. So some of you might find that doesn't actually hit your parabola. Then you know something's after going wrong. Okay, so something's after going wrong at that stage. So in our question, it'll show you when you're measuring 18 and up 38 that you should hit the parabola. That should be an intersection of both the parabola and the ellipse. Alright, so that point there. Alright, so that's a very important point for us. So what I'm going to do is I'm going to join that point to both our focal points. Okay, so actually I'll show you what I'm actually going to do here is I'm going to join that point to focal point C, but I'm actually going to extend that line on. What I'm going to do is I'm going to take that distance on my compass from that point we just found to our other focal point, which is A, okay, and I'm just going to add it onto that line. So see what I did there? So I took the distance from that point, so I call that point Z. Right, so that's our important point Z. Then that's the intersection of our ellipse and our parabola. So I took that distance Z back to A, which is our other focal point, and just extended it on. So you'll see that line there from C to this point here is our major axis. Okay, so I'm not going to go and measure that or anything like that. What I'll do is I'll just bisect it. If I find halfway, I can just add it on either side. Alright, so you'll see things are starting to get a bit messy, alright? That's why it's so important for you guys to use a sharp pencil, because in drawings like this, lines will overlap. Okay, so I'm just going to find the center, so we know how to bisect the line. So there's the center. So what I'm going to do is I'm going to take that's half the major axis, and I'm just going to add it on. So I'm going to go to the center, I'm just going to add it on both sides, and there you have it. Okay, while I'm here, actually, I'm going to draw the major circle, alright, because we're going to go and construct our ellipse in a second. So that's my major circle. Right, now we have an issue. We don't have our minor circle, but what we do have, we have our major axis and we have our focal points. We know by taking half the major axis, scribe an arc from the top or the bottom of the minor circle, we'll find us the focal points. So we're just going to work them backwards. So we're going to go to our focal points and we're just going to scribe an arc. Alright, so that distance there from A to that arc is half our major axis. Okay, and that's our minor circle. So what I did there, so I took half the major axis. Normally, what we would do is if we go to the top of the minor circle or the bottom, and we'd scribe an arc back on to the axis to find our focal points, where I'm just going to work in reverse here because we have our focal points, but we don't have our minor circle. And I'm just going to scribe an arc just to intersect our center axis there. Now, I'm going to go ahead and draw my minor circle. So I'm going to extend my compass to this distance where the arc intersects our center axis. I'm just going to draw that. So that's our minor circle. Okay, so that's our major circle. And there's our minor. Okay, now I'm going to go ahead and construct the ellipse. So using 60-30 from the center, I'm just going to bring that through. Bring that through the center. So you can see it's really starting to get messy. So this is what I'm talking about with a sharp pencil. It's so important. Right. So I'll just show you down here one of our rules. Alright, so if this is our major axis, okay, because our ellipse is that way, our major axis is horizontal. So our rule, when we hit the major circle, we go towards the major axis. Okay, so one of my 60-30s here hit the major circle here. So I'm going to go towards the major axis, and then you can just bring the minor circle intersection out. So that point there is a point on our ellipse, and you can just do that the whole way around. That's constructing an ellipse. Okay, that should be fairly simple. I actually forgot a 60-degree line. I'm just going to bring that through my two circles. There you have it. So there's the bottom half of our ellipse. Okay, and then it's the same procedure just to find the top. I'm going to find it a bit tricky here now because I have a lot going on up here. So I'm just going to try my best. And what you'll actually find is the ellipse goes inside the parabola. That's why I drew my parabola in heavy at the start, because I could see that from the question. So it's 30-degree line, so it's getting very messy at this stage. So that's why it's so important to use a sharp pencil. Okay, so I'm going to go ahead and find these points. There's one. And there's another one, because we know that's inside. That should actually be that point there. So I'm going to take it as that point there. Over here, there you go. There's another point. Oh, sure, there it is there. And obviously we're the end of the major axis, and then underneath there's the top of the minor, or the bottom of the minor, and there's minor points. So I'm going to go ahead and draw that freehand now. Now you can see the question is really starting to come together. I'm just going to go over that in a bit heavier, just so it stands out off the page. Okay, so obviously you guys will go through this a lot quicker than me. I'm just going through it slowly just to show you the principles. Okay. Right, now, so the last part is the bottom, so the arc DEF, okay? Now some of you might find this a bit tricky, but if you can see it, it's very hard, it's very easy to just recognize. Alright, so DEF, alright, and we're told is a tangent to our ellipse. Okay, so what we don't have, so this is an arc, right? So this isn't freehand, this is done with a compass, okay, but what we're not given is a center point. So what we're going to do is we're going to locate these points D, E, and F, alright, and we're just going to construct two chords, okay? Two chords. And when you bisect two chords, so we find the center of those, what you'll find is they will meet, and that will be the center of our curve. And we can use that as a radius then to one of the points. Okay, so I'm going to find DEF, and then we're going to construct two chords. So we're told that if I come down 34, so I'm just going to do a vertical line here just to help me with my measurements. As I said, I don't like measuring on thin air. Right, so there's 34, and then we're told to come down another 28. Right, so there's down 34, and then down 28. Okay, and another horizontal line there. So we're told F is off at 60 degrees from that point that hits our ellipse. So I'm going to just come up to 60 degrees. So this is down 34, and this is down 28. And where that hits the ellipse, I'm just going to pop off at 60 degrees. And I'm going to do the same on the other side. So there it is there, and I'm just going to come off at 60 degrees. Alright, and we're told it hits where it hits the 28. That's your point, so there it is there. So that's F, D, and E is at the bottom of my ellipse. Right, now we construct our chords. So I'm going to join D to E. construction, sorry. So join D to E, and similarly join E to F. Right, now to construct two chords, or bisect the two chords, sorry. So I'll scribe an arc above the line, below the line, and do the same on the other side. And where those arcs meet, bring them to the center. And what I'm going to do is I'm going to extend them on. And a little trick here, guys, is you can just bring down that one. Instead of bisecting the other chord, there's no need. That's our center there. Put our compass there. Extend it to D. As you can see there, it hits E perfectly. And should go on, hit F. Close enough. You'll get full marks. Once you're showing the construction, once you're showing you know how to do it, you should get full marks. So you can join that back up, then D goes up to the ellipse, and F up to the ellipse as well. And there you have our question completed. Okay, so the last part, DEF, just to go over it again. Okay, so I just said, or we can just see that on the curve there, if we construct two chords and bisect them, you find the center of the circle. But what I did was I just bisected one chord. So DE is a chord of the circle. Bisect that and extend extend it on the center, E vertically down. Use that as my radius, then bring that back to D and just scribe the arc, and there you have it. So that's question 6, the conics question from the 2020 ExamCraft question. Any questions, feel free to give me a shout on Schoolwise. Thank you.